Data moves the world, especially in urban mobility. The municipalities or, for example, service providers are collecting data and using it to improve their services and the places we live in. What data should be collected and how should it be used for urban projects regarding mobility issues and climate change? Those were among the main topics of this year's Prague City Data Congress, held by Operator ICT. And one of the speakers was Fábio Duarte, the principal research scientist at MIT Senseable City Lab. Fábio Duarte wants to improve urban public spaces with the available data, preferably to eliminate as many cars from the city streets as possible. Among other projects, with his colleague, he has worked on autonomous robotic boats in Amsterdam and optimizing taxi rides in New York. What data is needed for these solutions, and in what cases should investment be made in infrastructure to help collect that data? That's the topic of today's Simply Clever podcast, recorded directly at the Prague City Data Congress. Okay, Fábio, welcome to Simply Clever podcast.
Thank you very much for inviting me.
It's somehow funny for me that you also call yourself the urban planner and not some kind of like data analyst, because that's pretty much what you do, analyze the data and then, of course, work them.
Yeah, so actually there is a very interesting question, because there is a new field in the urban studies realm, which is called urban science. And actually at MIT, we have a new program called urban science. And urban science is basically what you said, now that we have so much data available, can we have a scientific perspective to understand cities and to design and plan cities? So I agree with you that in the future, very soon actually, we're going to have the first classes coming out of MIT as urban scientists. Yeah. And this is a very innovative thing, I think, for us.
What are we going to talk about is probably one of the biggest problems the current cities have, which is let's say the traffic, the mobility, how the people move around the city. So do we agree on that the problem is too many cars within the city streets?
Yes, we agree. We have too many cars.
So how to solve that with data? We need to collect data. I found a little interesting remark in your presentation here on Prague City Data Congress that it is some kind of a chicken egg situation sometimes, that you don't have questions, so you don't need data, and you need to collect data to have the questions. So how is that? We need to collect data to solve this problem.
I think we have two problems here. Actually, one is data, but the other one is behavioral. For instance, I don't need to have any data to tell you that using tram or bus or train is much better than using cars for the environment, for instance, or for traffic. So I can put many more people in a bus than I can put in a car. So I don't need much data to say, okay, look, if we're going to point E to point B and there is a tram line, it's better to take the tram. So I think there is one part of the problem that data will not help us at all. It's a behavior change. This is much more difficult. But also, I think we are in this very rare moment that we have so much data and we can learn more about cities with data. And I'll give you an example. So, for instance, transit and transportation authorities, they try to rely on transit and transportation data. So they are measuring how many cars are crossing a street, how many people are on the bus, etc. However, oftentimes the best data does not belong to the problem that you want to solve. And the example is cell phone data. So when you have only data about people moving on buses or in cars, you have a captive audience. So they're already moving. They have to go somewhere. If we could monitor, for instance, cell phone data, we would also be monitoring those who are not moving or who are not using any type of transportation. They are walking. So then we can understand how people want to move in the city and how people are moving in the city that are not captive to your systems. So that's, I think, a very good lesson that sometimes the data that you most need to solve your problem does not belong to the field of expertise that you are trying to solve.
Yeah, but from that I get that you probably need to collect as much data as you can, even though you don't see the problem at the very first moment.
Yeah, so I think abundance of data is not a problem, but only displaying this data will not solve your problem. If you have lots of data, I can describe you in a very precise way. However, I still cannot find a solution for your problem in the case of city. So I think having lots of data is not an issue, but only having lots of data will not solve our urban problems.
So maybe a little bit too broad question, but is there any specific data set the city should collect to get somehow an idea what's happening around in traffic, let's say? But as you mentioned, you need to also the data about the on foot, let's say, movement around the city. So is there anything that they should focus on, and not to forget, let's say, to start with this data set?
Yeah. So I think that if I would have to select one data set, okay, look, you are here to solve Prague's mobility problem, and you have the right to have one data set, only one. Which data set would you like to have? Cell phone data. And why? Because we know that we have more people using cell phone than we have people walking, taking tram, taking buses, taking any other mobility. And by having this cell phone data, I can derive from them if people are moving or not, in the first place, when they're moving, which mode they're using based on the speed. So if I had to okay, look, come here, try to describe and solve mobility problem in Prague. What's the data set that you need? Cell phone data.
Okay. And what is the next step? How to analyze that? To, let's say, see how the data moves, where do they gather, and so on?
Yeah, because for instance, if I have cell phone data and I know, we are here in Prague today, and I know that, okay, Fábio is moving in this path frequently, every day, the same path. Do we have a tram that could serve his path? If I do have a tram, could I send him a message, okay, look, instead of, I know that you are using car because your average speed in this trajectory is more than 30 kilometers per hour. Then I can send a message, do you know that there is a tram line doing exactly the same path and you would spend, let's say, 5 minutes more? And the same thing can happen to also those who are not moving. Now I can see that there are another group of people who are not moving. And they're not moving because they don't want, or because there is no public transportation offered to them. Perhaps they don't have enough money to buy cars. We're not providing any public transportation, and therefore they're not moving. So I think this is the type of questions that we can start asking ourselves and then finding solutions through cell phone data.
Maybe again, it's a little bit silly question, but you're a scientist, I'm not, so excuse me. Good. But is this some kind of approach you used, for example, in Amsterdam, where you started this robot service you've presented here?
Yeah. So in Amsterdam, we had the chance also to present more or less what was the problem about robot. So robot is a project that we developed at MIT with AMS Institute in Amsterdam. And the problem started when the city came to us and said, look, let's work together to find autonomous solutions for Amsterdam. And Amsterdam has 100 kilometers of canals. And our thought was, okay, why we should deploy autonomous cars if we can perhaps develop autonomous boats? And then the second step was, as you said, collecting data. And we had data from transit, from cars, from boats navigating, and then we started analyzing all these flows in the city to understand what was the best use of autonomous boats in the city of Amsterdam. Yeah. So data was our initial step towards a project that eventually ended up with autonomous boats navigating in Amsterdam.
I like the idea because, like when you start a project like that, you don't, let's say, mess up with the current traffic system, let's say, and you implement a new way which is kind of like not interfering with the current modes of transport. That's nice.
Yeah, I think so. I think sometimes we believe sometimes too much that new technologies will solve all the problems, and we forget to see, okay, perhaps we have old technologies that are still working or could work better if we give some data push, let's say. And this data push to old technologies might revive them. So this is more or less what we are trying to do with Amsterdam canals. Yeah. They are there from 500 years. They have been working very well. Perhaps we don't need to pave the canals as they did in the early 20th century. But if we can give some data push to the canals, we can find other ways of using these canals, solving current problems.
Yeah. What's interesting on this project is that you're not only solving the mobility problem, like moving people from point A to point B, but also dealing with trash, which is a little bit surprising. And here in Prague, in your presentation, you kind of put this garbage problem a little bit like as a more important. So was it really so important to solve how the Amsterdam moves the trash around the city?
Yes, because Amsterdam, most part of the cities, they have underground bins. So you have to walk more or less 90 meters to bring your trash to underground bin, which I think is a very nice system. You have to have some effort and walk with your trash. However, they cannot implement the same system in the city center because it's a historical site, but also because if they dig the sidewalk, they might harm the wooden infrastructure of the canals and they would collapse. So in this case, we thought perhaps we could bring trash collection back to the canals. They used to be collected through the canals decades and decades ago. And we're bringing the trash collection back to the canals using autonomous boats. The advantage of this is not only, but why? Why this is so important for the city? Because by bringing back trash collection to the canals, we are removing all the heavy trucks out of city center. So this is another important aspect of this project.
It has more layers. Layers, about like bringing or reviving the old technologies here, what is also nice about this project is you're basically combining like the old technology or old ways of doing things and the new technology, the autonomous tech, let's say. So I guess this is something, and I'm also doing the podcast about sustainability. Sometimes it's still circling around like this. Let's say, remembering what we've done before and sometimes not inventing the wheel and maybe just improving the current system with some old knowledge, let's say. Yeah, that's pretty nice.
Yeah, another example so you ask, okay, if you want to solve the mobility problems and I have one data set, which would be cell phone. If I had to choose one urban infrastructure to make them smart, to create a smart cities out of one infrastructure, I would select street lights. And why street lights? Because they are everywhere, right? They are evenly distributed across the city. They have a verticality going a few meters underground and a few meters above ground, and they have energy supply. So what best infrastructure you might have to deploy sensors to collect data of the urban life of the city than street lights. However, most cities, when they think of street lights, they only think, oh, yes, I can put a LED, I can dim down this light, I can make it brighter. This is not enough. We have this powerful network of sensors in the city that we should use.
And should we implement again? We're coming back to the question, like if we need to collect data first, but should we install them with all the sensors you've mentioned, even though we might not have the specific idea what to do with them at the moment?
Yeah, I think we should not. And let me tell you why. Because I think sometimes technology, the most kind of the principle of technology is to be obsolete very soon. Otherwise, if we don't have obsolescence of technology, we're not going to have new technologies, right? So it's very expensive to deploy too many sensors. So if you don't know more or less what you want to do, you risk to deploy sensors, to use today's technology for a problem that tomorrow we might have a better technology. So I think there is a cool balance between, okay, if you have the data already available, like cell phone data, use it. But if you have to deploy sensors to get data, so be very careful what problem I'm trying to solve, and then you deploy the sensors.
So it's maybe a little bit better to be to use in a smarter way the infrastructure we already have, and to find some solutions out of that.
Yeah. And sometimes the data is freely available, right? Cell phones data, you have to have an agreement with the telecommunication company. But the government has given them the rights to operate. So the government should have the rights to use the data. But sometimes we have data freely available. I will give you 2 examples from companies, but let's say Google has Street View images from more than 400 cities in the world. And they have a very important visual information about cities. Let's use that. Or we have Twitter. 50% of Twitter tweets, they are geolocated. So we can understand, at least in a first phase, you can understand more or less how people move, which part of the cities are more alive or not, using available data. So I think deploying the sensors should come after you gave a first assessment which data we have already available. Yeah.
With Fábio Duarte, we agreed that the service providers need to work with the available data to improve their products further. One example is BeRider, the electric scooter sharing platform in Prague. They adapt the zones according to user data. With this information, they can work closely with the municipalities and deal with local mobility issues and, for example, parking, says the CEO of BeRider, Charouz. I would assume that for the mobility service as BeRider is crucial to, let's say, monitor the data, the user data, where the people ride the scooter, where they end the drive, and so on. So you need to look closely on this data to improve the service.
Yeah, I think looking at data is crucial for any business, let alone a mobility service. So within DigiLab, we actually have a whole division of people that are involved in data analytics. So as you said, extremely important. BeRider is on its 3rd birthday now. So there was quite a development in the zone of operations, for example, which we change on a very frequent basis. The way it developed was that we started with a very large zone that covered nearly the entirety of Prague. And then we looked at how the users actually use the service. So we left it very open and gave the users the opportunity to try it wherever they needed to use the service. Based on that, then we started to shrink the zone to keep only the best hotspots and the best locations for the users and for us as well. The thing is, once if we keep the zone too open, we still have a limited amount of scooters. So if we keep it too open, I know shrinking the zone sounds bad for the user because they cannot, for example, go anywhere they want. But what it means is that we condense the scooters as well into that smaller zone, and it means there are more scooters available in the hotspots. So it's really tough to find that balance between zone size and amount of scooters. So as I said, we started shrinking the zone based on the hotspots. Right now, I think we have a very curated map of the ideal locations after 3 years. It was a long journey, but we got there in the end. What we do as well, because the patterns of behavior may change during the time, new residential areas may sprout up, new bus stops, restaurants, whatever. So we always look back at the map, and we value user feedback as well. So what we look at is, for example, map opens, meaning user can open the map, open the application, and even though he doesn't do a ride, because maybe the zone isn't there, we register that click or that map view, and if there's enough of them, then maybe we consider opening a zone there. So that's maybe a good tip for someone who doesn't have a zone at his house. Get 100 friends to open the app every day for maybe a month, and then maybe the next month you'll have a zone there. So the next thing is we have like an open survey where you can click on the map to request a zone location there as well.
Yeah. And of course, like the very important thing is where the scooters are parked, let's say, which is also something that might be interesting not only for you as a mobility service, but also for the municipality, that this is some kind of data they can use to, let's say, rearrange the parking zones and work with you closely within this process.
Yeah. So we collect a lot of data, as I said, especially on where the ride starts and where it ends. We're willing to share, and we are sharing all of this data with the city. And a good example of how this open sharing has worked out is for example, in Prague 7, where based on our data on ride ends, we managed to, in combination with the city, we managed to launch like a pilot of new parking spaces that are utilizing dead zones. I don't know what the correct term is in English, but it's basically parking spaces where they're too small for a car, but they're big enough for a scooter, bike, or whatever shared mobility device you can imagine. So there's many of them in Prague 7 right now. I think the project is going very well. And you can see that people really use these zones. We even have a feature in the app where we can promote the use of these zones. We call them bonus zones. So if you park in this zone rather than 5 meters across, then you actually get some credits.
You have some incentive to make your users do
exactly
use these places.
But even without the incentive, it works. The interesting thing is that parking is probably the most dividing point between mobility services and the population of the city, especially the population that doesn't use the service. And I understand that because, I also live in Prague, I also drive a car. And when I park outside my house, I kind of expect to have that, space there. And if a BeRider or any other shared mobility service car or vehicle is parking there, maybe I'm a little bit angry, right? I understand it. But the thing is, the people who don't think about it don't see that this shared vehicle is maybe used by 10 people and not one. And that a scooter or one parking space for a car can actually fit 12 scooters. We know, we tried. So that's the thing. The demand for mobility is growing in every city. And everyone having their own car is just unsustainable. So this is one of the solutions. I'm not saying BeRider is the only solution. It has to be in combination with the other services, with public transport and all of the other services that we have. But it is the only solution to allow the city to function somehow in the future. Because if everyone just jumps in their own car, we'll just stop the city altogether.
Let's get a little bit back to mobility. You've also presented here the New York use case, the minimum fleet project, which was basically about like trying to let's say lower the necessary amount of taxis or cars generally traveling around the New York. The project is from 2017 to 2018, if I'm not mistaken. So like let's say 4 or 5 years ago. Has the situation already changed? Had somebody used your knowledge, your data, and improved the situation?
So this is a very interesting story, because let me explain very briefly what minimum fleet is about. So minimum fleet, we knew that the city of New York, we had lots of cabs, right? We have 14,000 cabs more or less, and 80,000 running at any moment. And per year they have 150 million trips. And the city released all this data. And we started putting some research questions, and one of them was minimum fleet. And the question was the following. Could I coordinate the taxi trips in a way that I can use less taxis to make the exactly same trips? And we run several mathematical models, network analysis, etc. And then we found that, yes, we could reduce the number of taxis in Manhattan by almost 40% without changing any trip. And why? Because usually if a taxi comes and drops some passenger off, the driver either stays there idling or starts driving around. If with this 150 million trips, we found some patterns, right? Okay, if the driver is dropping somebody off here, the probability of passengers requesting cabs in 5 minutes, in 10 minutes, in 15 minutes, in different parts of the city is that in percentage. And then we start, okay, if I send which car to which location, I would optimize this behavior. So we prove this to New York, and what happened next? There's another very important characteristic of MIT, but also the lab. MIT has the say, is mens and manus, meaning head, brain, and hands. Yep. Meaning that we are there not only to make science for the sake of science, but how can we make science to improve everybody's life? Okay, put it in practice. So out of this project, one colleague of mine who led the research, Paulo Santi, with other colleagues, they have now a startup, and they are providing this service to some cities. So I think this is a very nice thing of MIT, that okay, let's do science, let's push science forward, but if possible, how this science can transform reality.
Yeah, so this data don't only like goes to the
journals,
to the journals and
journals,
so on, yeah,
yes,
being on the cover of the Nature, but it also gets into the practice, and so on. That's nice. I was just thinking you use the data about the taxi drives, let's say. How much would that change if you encountered also the data from other modes of the transport, because you have some sharing services, shared mobility, and so on. So this might have been a huge change.
Yes. So we had another research done later after that we had some cities where they have competing systems. So let's say we have some cities with Bolt or Uber or taxis. The consumer thinks, okay, I have more options, therefore I will be better served by this competition, right? We proved also using all the mobility of these apps that we had access for a few cities, saying that actually competition brings benefit up to a point. After that, it does not bring any benefit at all, either because drivers stop driving, because, oh, I don't have enough passengers, or drivers start competing for the same passengers. So what we tried next was, what if they have this competition, but we have a centralized system that, okay, when you call a shared mobility, you call this central command.
Brain.
And there's, okay, look, these requests go to Bolt. And why? Because Bolt would arrive to this passenger faster than the Uber or the taxi. So you will still keep competition. So taxi and Uber, they are there. Obviously, if Bolt has more cars on the streets than Uber, the chance that they will get more trips are higher. But who is sending the driver to the passenger? is a central command, not the drivers competing with themselves.
But by central command, you mean some kind of algorithm?
Yeah, exactly. That can be managed by the city, right? So the city, okay, look, you can operate here in Prague, Uber, boats, taxis, you can all operate here. But who is dispatching your vehicles is this public administered system or algorithm.
And your touch point is some app or whatever, like
Yeah,
multimodal app.
exactly.
Yeah. But in that case, you need all the passengers, let's say, to rely on this advice, this let's say, information.
Yeah, you don't need to. And let me tell you why. Because the whole point is that the user will realize that, okay, oh, if I use this single app, instead of having 3 apps, taxi, boat, and Uber, if I have only one app, and talking to my friends, oh, I've been waiting here for 10 minutes. So, why? I'm waiting only for 2. Yeah. Okay, let's try this other system.
Okay. So yeah, so it gets like, somehow it naturally gets to understanding that I need to trust this app to move as easily as possible.
Yeah.
Nice. So how does that work? Have you already created this central brain somewhere?
So we have the same startup. They are now doing the minimum fleet, and they have this same algorithm part of the company. So this is another service that is important to bring. So in this system, we are comparing, let's say, Uber, boat, and taxi. All of them, they are private services. Yeah. So what is also interesting and should be more interesting is to include in this platform also public transportation and bicycles and scooters. So, okay, look, these are all the options that you have. So it's true that if you go on Google Maps today and say, oh, I want to go from my hotel to the airport, Google will give me, okay, this is how you take a tram, a bus, but also you have this option. Yeah. Let's say, currently, I don't know in Prague, but usually it's boat, but they could give other options, right? That's fine. However, the only decision, you have 2 decisions there, which is price and time. So you have to more or less go, should I pay more and arrive faster? Should I pay? But what if the city has some goals, for instance, decrease CO2 emissions or decrease NO2 or pollution in general? So if we have this controlled system, let's say that we have some points. Okay, look, you use the app. If you select option tram, and then I have your cell phones, right? So you are selecting option 1. Therefore, you are polluting much less than somebody who has selected car, even an electric car, because you have 100 people on a tram. Then you start receiving these points back to pay for tram, to pay for Uber, to pay. So I think the city, if cities start using this information and adding to this platform cities goals, such as one of the goals is to reduce CO2 related emissions, then the city can use this platform not only to minimize traffic, but to achieve some of the sustainability goals.
Yeah, and again, you're using the live data to improve something.
Yeah.
Okay, Fábio, thank you very much for the interview.
Thank you, it was a pleasure.